All right, so this is our first set of inverse functions. And what we're going to do is we're going to work with our natural number, e. So this is a number that you don't see very often, but it happens in nature all the time. Anytime there's growth or decay, you will use the value e. This is an irrational number. It represents the number about 2.71828, and it continues on, but it doesn't repeat itself, just like the value pi, 3.14, and it keeps on going forever. So when you see the variable e, it's not a variable. It's actually a number. The x is your variable. That is the value that you're going to replace, okay? So, excuse me, so this is our exponential function. What undoes e to the x is ln. ln is our natural logarithm. So anytime you're trying to get rid of e, you're going to use ln. If you have ln and you're trying to get rid of ln, you will use e to undo it. So to show that this is an inverse function, we're going to go ahead and graph e to the x. So you're going to need to use your calculator. Your calculator does have an E button. If you have a TI-84, you can, there's one of two ways to work. If you see down, I'll show this, down the right-hand column is a bunch of keys. You'll see right above where the numbers start, you'll see a log key and an ln key right underneath it. Well, the second function, so right above, so in between the log key and the ln key, you'll see e raised to the x power. So that will be a second function, e to the x. On your TI-30, you'll need to find the ln key, and then right above that will be your e to the x key. Also on the TI-84, right above the division sign, there is an e key, so that would be your second function, e. And then you'll use the little hat key right above that to use as your exponent. So you can go either way. I prefer the e to the x because it's already set up where your x value is going to be in parentheses, which is going to be important. Okay? All right, so again, the x value is our independent. That means I can use anything I want. So if I use the number 0 for my x value, what I have is e to the 0 power. Anything to the 0 power is always 1, every single time. If you don't trust me on that, go back to the exponent videos and watch why anything to the 0 power is 1. If I plug in 1, I end up with e to the first power, which is my irrational number, 2.718, and it continues on. If I use a negative 1, remember a negative exponent means it is 1 over e to the first power. So it's 1 over that. So when you calculate that, you get, oh, I have the wrong one. 1 divided by e to the first power is how I'm putting this in. So e to the first power, so 1 over that is 0.36787, and it keeps on going. And then if I have 2, I'm going to go e raised, I'm going to go e, oh my gosh, e raised to the second power is, so this is e raised to the second power, is about 7.389, and again, it keeps on going. And then if I use negative 2, that's 1 over e to the second power. So 1 divided by e raised to the second power is about 1.135333, and it keeps on going. Okay, so let me graph this. So when x is 0, my y is 1. When x is 1, my y is about between 2 and 3, so almost to 3. When x is negative 1, my y is 0.36, so it's not quite half. And again, this is just a sketch. When x is 2, my y value is 7.3. So 3, 4, oh, come on. 3, 4, 5, 6, 7, 8. So it is somewhere in between 7 and 8, but not quite half. When x is negative 2, my y value is 0.13. So there's negative 2. So what's happening is your graph is getting closer and closer and closer to 0, but it doesn't include the 0. And this is, again, as we talked about in the exponential function, because this is an exponential function, you'll see it has the same shape, right? It has the same shape as our other exponential function. It is gradual climbing, and then once you get to a certain place, boy, it really takes off. Okay, so that's growing exponentially. All right? Then, when I come over here to my ln function, what we're going to find is, remember, our inverse operations, it switches the x's and the y's. Okay? It undoes each other, right? They're inverse operations, so they will undo each other. So now you're going to use your ln button on your calculator. Okay, so now is where you're going to use your ln button. So if you have ln of 0, what you're going to find is there is a problem. All right, you cannot have a 0 as a natural number. So what that means is when x is 0, there is no value for ln. Okay, so this is going to be an error. You're going to find an error in your calculator. When x is 1 and you do ln of 1, you're going to get 0. Well, remember over here, when we said x was 0, our y was 1. Now, when x is 1, our y is 0. So you can see that our numbers just flip-flop. They are inverse of each other. When I have ln of negative 1, you're going to have another error button, right? So we can't have, ln's cannot equal 0. I'm sorry. X cannot be, we'll do it this way. X has to be greater than or equal, greater than 0. Okay, that's our domain. So the domain changes a little bit in an ln, but it is the inverse of the natural number. So when I plug in 2, if I have ln of 2, I'm going to end up with 0.693. Okay, so when I have x is 2, my ln is 0.693. If I plug in 0.693 in here, I end up with about 2. So if I had 0.693 in this, it's just because we haven't used it yet. So 0.693, my y value is about 2. Okay, so again, it's inverse operations. Where'd my green go? Okay, so if I had 1/2, what is ln of 1/2? Is negative 0.693. Okay, so if I had x is 1/2, I'm going to have a negative, here's negative 1, so 0.693. So what happens is my graph goes like this. And you can keep going if you want to plug in more points for ln. Just remember, with ln, with the natural log, your values have to be greater than 0. All right, it has to be greater than 0. So what happens is this graph approaches when x is 0, but it doesn't touch it. So again, we have two graphs that are mirror images across that identity line, or y equals x line. Okay, so these are inverse operations. ln does undo the e. The natural log undoes the natural number. And now we're going to go from there.